int and double and all the ones we care about.
And things like foreign pointer as well, which consist of two number in 2 parts.
So we can look at a few other things here. I'll look at an int map and we'll have a look at how byte strings are represented.
Yeah.
I'll see the adapted versions.
Sorry? Yes, and we'll look at the adapted.
How does it show function? Probably not.
It doesn't show them. So at least it doesn't crash, but it doesn't show anything.
That's not really viewing nothing.
Yeah. So that was our size balanced binary tree. There's of course we have Patricia trees, int map, and they're quite different. They're very well balanced, and they're a little bit more complex. They store a prefix, which is the bit in the int path that is the key. So the most significant or least significant bit in the key is used as the first node's index, and then you sort of walk down that path of bits until you get to the value you care about. And here we see all the leaves are not shared, so we just have 4 here. So we store pairs of x and y. But we have bin nodes where we actually do have values stored. So if we find 2, 1, or 2 and 1 here, we actually find those stored in the constructor. I'll just bring up the source of the map. And so that's the data type. You can see the key in tip node is unpacked. So that's the key that's been unpacked into the closure. And in a bin node, we have the prefix bit, which is an int, and any mask that's used to derive that prefix, and then 2 subnets. So we'll see here's a bin with the mask and the prefix, and then 2 pointers to the subnets. So you can build some quite pretty data structure this way. You start to see quite complicated things. I'll just make a few more. They're quite pretty in the larger thing. But they do start to illustrate how many indirections are involved in the standard polymorphic representation of these polymorphic data types, which made me immediately think, okay, how can we get rid of n pointers from this structure? And one way to do that is with associated data types, where we have you can have a class that says, for my type A, let me define a custom representation that will actually be used in the operation on this data. And so you can imagine constructing a list, which is normally polymorphic in A, it's a uniform representation. Instead, for every element type, we run an instance that defines a specific unpacked list type. And as long as our general functions parameterized by both the data type and how to access it, we can write a generic list library that will use a more efficient representation. So list was one of the first things I did this way. You start describing your data type. It's a list of some A where I'm not going to tell you the representation, and it has a way of constructing the constructors and taking them apart. And then you can write all the usual list functions exactly as you used to, except they're now parameterized by the actual data type that will be used. And just show that. So all the list functions are exactly the same as in the list library, except we had to replace cons with function cons, which would be taken out of the dictionary now for the instance. And the other constructor is empty. And head and tail are instance methods. And then the thing is, the actual instances themselves, we'll go and find some of the instances. For every element type now, we have to define a representation of it. So if I have a list of int,
Is there a overhead involved in using dictionary for type classes, or is that why you inline all of them?
I inline them all anyway because they're in the worker wrapper style to encourage inlining. But we really do want PHC to statically resolve all the dictionaries.
And then they get
So it's going to replace all the consors with the actual concrete type.
And do you see that in the visualization of the vehicle, that there is a dictionary or something?
No. You just see, well, we'll have a look in a second. So I just want to show you here's the concrete type we're going to use. It's exactly the same definition as for the normal polymorphic list, except here, the element we know is an int, which I'm going to represent as a strict int, and I'm going to unpack it. So we're going to save n pointers hanging off to those integers. And then all of this is just generated generically with a SYB style script. But we can, so we can have a look at the impact this has. So, if we think of a list of pairs, let's have a look at just our list of pairs that we've had originally. So that's a list of quite a lot of nodes, and there's lots of pointers hanging off here, and there's a sharing involved. But we can replace the pairs with adaptive pairs that unpack their components, yielding a normal regular list, but the pairs will be written like that. And I'll just put an extra bit on my parentheses in our place. And that will be data tuple. And tuple. Okay, and that will make it small, as you can see. You can already see the shape is a bit different now. So here, where we used to have a pair, which was a little comma constructor and then 2 pointers and 2 actual values, the ints components have now been unpacked in the constructor. So we've saved 2 times n pointers already.
So it's possible that this could actually cause an increase in memory footprint because we lose sharing.
We lose sharing, and it's very clear that sharing is lost here. Yeah. So I haven't done any benchmarks to show. All the benchmarks I have done have shown that everything's gone faster.
Yeah, sharing of it.
Yeah, sharing it, exactly.
Sharing is fairly cheap than having the, I mean, not sharing is fairly cheap, but the bigger thing.
Yeah, so do I want a pointer plus a header word plus the int, or do I just want to strip all that away and store it directly in the constructor if the thing that's storing it? And then the next step is to use the adaptive list of these pairs. So we replace, we'll have to take this from list. And our type is now adaptive list of these guys.
Why do you have to specify the type actually? Don't you specify int to 4?
Yes. List of list. There we go. Everything, all the pair components have now been unpacked into the cons constructors, and we just have a very regular list.
You should float the window.
There we go. So this is using GTK's Cairo vector graphics frame, so it scales nicely. There we go. So that should be a lot more. That should be a lot more efficient. For lists, things like map were 20 to sort of 40%. They're about twice as fast. We remove most of the data structure. About half the data structure is gone on this, and so we'll go a bit faster. So I think
in a simple case where you've got atomic variable.
yes, yeah.
Very atomic type.
Yeah. So it's only for the atomic types that the instances of the atomic.